Hi guys, I welcome you back. Today we are still continuing with the topic of bonding. From our previous topic, we learned about ionic bonding. Today we are going to continue to another type of bonding, which is covalent bonding. So with covalent bonding is the bonding between non-metals, through the sharing of electrons, remember that with the ionic bonding, we mentioned that it is the bonding between metals and non-metals through the transfer of electrons. Now, talking about covalent bonding is the bonding between non-metals through the sharing of valency electrons. So the purpose for the sharing of these valency electrons, it is in order for the atom to obtain a noble configuration. When you're talking of a noble configuration, we are simply talking about the number of valency electrons. They have to be complete. The valency shell has to be complete. If it's an atom which only have one shell, that means that shell, it has to have 2 electrons. And if it's an atom that has 2 shells, the valency shell must have 8 electrons. So that is the purpose for the bonding. So here now we have an example whereby we are going to show the bonding between oxygen and hydrogen for the formation of H2O, which is water. So now I'm going to fill the electrons in the structure below here. So the bigger atom here is oxygen. Oxygen, it is in period 2. So by the reason that it is in period 2, that tells us that it has 2 shells, and it has a total of 8 electrons. A total of 8 electrons, where the first electrons are in the first shell, and the other 6 electrons are in the valence shell. And remember that hydrogen only have 1 shell because it is in period 1, and therefore it has 1 shell, and it has the number of electrons. It has 1 number of electron. So which means that it is in shortage with the 1 in order to obtain a noble configuration. So this means that oxygen and hydrogen, they are both going to share a single electron. So that means that oxygen is going to provide its 1 electron, and one hydrogen provide its another electron. The same thing with another hydrogen to the same oxygen. So this simply means that now we can fill the remaining ones for oxygen. So now, if we can count the total number of electrons around oxygen, or in the valence shell of oxygen, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. So now this tells us the oxygen has a noble configuration. And the same thing, if we can count for hydrogen, is 1, 2, 1, 2. That tells that hydrogen now also it has a noble configuration. And by the way, here we have of a skeletal structure of how we draw H2O. So this tells us that oxygen, it is bonded to 2 hydrogens, and they are bonded by a single bond. This single bond, it shows that only 2 electrons are shared between the 2 atoms. Just like we have here, 2 electrons are shared between the 2 atoms. That's why it forms a single bond. This line here, we call it a single bond. And this single bond is formed when 2 electrons are shared between 2 atoms. That's the structure for oxygen. Now let's go to another example where now we are going to show the formation of ammonia gas. Ammonia is a covalent compound, which means that it is formed through the covalent bonding, the sharing of electrons. So ammonia, we have nitrogen and hydrogens. Is nitrogen bonding with 3 hydrogens. So what now we're going to do, we're going to fill up the atoms. You're going to fill up the atoms. You're going to fill up the atoms. All right. So now, because nitrogen, it is in group 5. Group 5, that tells us that it is in shortage of 3 electrons in order to obtain an octet configuration, because it has a valency electrons of 5. So that tells us that it's going to share 3 electrons with 3 hydrogens in order for it to obtain an octet configuration. This is what it means. This means that hydrogen is going to come with its electron, and ammonia is going to donate its single electron in order for it to share with hydrogen. So the total of the electrons shared between nitrogen and this hydrogen is 2 electrons. The same thing with this hydrogen and the same thing with this hydrogen. Then in total, this makes 1, 2, 3, 4, 5, 6, 7, 8 electrons to be shared for valency electrons of nitrogen. Now there are 8. That means that nitrogen has now obtained a noble configuration. The same thing with the hydrogens. Hydrogens 1, 2, 1, 2, 1, 2 each. That means that hydrogen, it has now obtained a noble configuration. And we also show that by the structure here. Like I said, a single bond tells us that the number of electrons that are shared between the atoms, there are 2. 2 electrons shared between the 2 atoms. Nitrogen has shared 2 electrons with this nitrogen, and with this one, and with this one. So what we can clearly say is the total number of electrons that are shared in the formation of ammonia are 6, because it is 2 electrons here, 2 electrons here, and 2 electrons here, gives us a total of 6 electrons shared. I believe I'm making sense. Now, going to another example, where now we are going to show the bonding of carbon dioxide. Carbon dioxide, which is carbon and 2 oxygens. Now, I want us to note something here, because between the 2 examples, for carbon dioxide and for ammonia, and even for oxygen, we can see that we have what we call a central atom. There is an atom that stays in the middle while other atoms are surrounding it. Now the question is, how do you know which one is a central atom? This is how you know. You are told by the formula. You can see that carbon we have only 1 carbon here, and we have 2 oxygens. So this tells us that the central atom is going to be the atom that has the smallest ratio between the number of atoms. So the atom that has a small number of its presence is going to be the one that's going to be our central atom, while the remaining atoms are going to surround it. Okay, now going to carbon dioxide. Same thing, I'm going to fill up the electrons. So remember that carbon, it is in group 4. That means it has 4 valency electrons, which tells us that it is in shortage of 4 electrons in order for it to obtain a noble configuration. So that means with oxygen, it is in group 6. It has 6 electrons, which tells us that it is in shortage of 2 electrons in order to obtain an octet configuration. So that tells us that for oxygen to obtain an octet configuration, it has to share its 2 electrons. So that means that if oxygen is going to share 2 electrons, carbon will also have to share 2 electrons for equality of sharing of electrons, because there is no how one atom can donate more than another one. They have to donate equal number of electrons. So if oxygen, it is in shortage with 2, That means it is going to share 2, and carbon is also going to donate 2. The same thing with this other oxygen. So now if we are to count the number of electrons around the valency, we are going to say for carbon is going to be 1, 2, 3, 4, 5, 6, 7, 8. That's for carbon. Now for oxygen, you have to include its valency electrons. We have to include its valency electrons. So that means if we are to count for oxygen, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's for oxygen. So that means that we have obtained a noble configuration for the 2 atoms, which is carbon and oxygen. And this is how we show the bonding of carbon dioxide. Now, notice that here we have 2 bonds, 2 single bonds, which we can call double bonds. And remember that we said a single bond is made up of 2 electrons. So that means if we have double bond, we have a total of 4 electrons between this oxygen and this carbon. The same thing with this one. Between this oxygen and this carbon, we have a total of 4 electrons, because a double electron is made up of 2 single electrons, and a single bond is made up of 2 electrons. So the total number of electrons that are shared in carbon dioxide is 8 electrons. So that is the bonding of carbon dioxide, ammonia, and water, which is H2O. Now, I want us to touch on the properties of covalent bonding. Properties of covalent bonding or covalent compounds. The first property is that they do not conduct electricity. They are poor conductors of electricity, even when they are in a molten state, even when they are in a molten state, they don't conduct electricity. Why? Because if you can see here, there are no free mobile electrons, but rather all these electrons are tagged between the shells or in their orbitals. Then the second one is that they are insoluble in water, but soluble in organic solvents. Organic solvents, we can talk of ethanol. Organic solvents, we can talk of petrol, we can talk of oil, we can talk of paraffin. Yeah, those are what we call organic solvents. So organic compounds, they are not soluble in water, but rather they are soluble in organic solvents. Then the last one is that they have a low melting and a boiling point. The reason why they have a low melting and a boiling point is because of a weak force of attraction between the atoms. You can see that in the formation of those compounds, it is only the sharing of electron. That means that the bond between carbon and oxygen is too weak. Unlike in ionic bonding, whereby we have charges, opposite charges attract. There is that strong force of attraction between metal and non-metal because of those charges that are opposite. But with this one, there are no charges that are formed. So because of no charges that are formed, that forms a weak force of attraction, which we can say that intermolecular forces and intramolecular forces. Those are weak forces of attraction between them. Thank you for watching. Kindly subscribe and share this video with your siblings, those who are doing GCSE. Thank you.